Imagine walking into a modern factory where the final product is not a phone, not a car, and not an ordinary flying toy. It is an AI drone, a flying machine designed to see, think, avoid obstacles, follow targets, inspect buildings, monitor farms, deliver small packages, and fly with very little human control. But before an AI drone ever takes off, it goes through a highly detailed manufacturing process inside a high-tech factory. The process begins in the design department. Here, engineers create a complete digital model of the drone. They design the frame, the arms, the motor positions, the battery compartment, the camera mount, the GPS location, and the internal wiring channels. Every part must be planned carefully because drones must be lightweight, balanced, strong, and stable in the air. Engineers test the design using computer simulations. They study airflow, weight distribution, battery placement, cooling, and how the drone will react to wind or sudden movement. If the drone is too heavy on one side, it may drift. If the frame vibrates too much, the camera footage may shake. If the electronics overheat, the AI system could fail. Once the digital design is approved, production begins. Inside the warehouse, thousands of components arrive. Carbon fiber sheets, plastic resin, copper wires, brushless motors, batteries, camera modules, AI chips, flight controllers, GPS modules, sensors, propellers, and communication boards. Every component is scanned, logged, and inspected. This helps the factory track each part from arrival to final assembly. The first physical stage is the drone frame. Carbon fiber sheets are cut into arms and body plates using CNC machines. For some drones, lightweight plastic shells are produced by injection molding machines. The frame must be light enough to fly, but strong enough to handle vibration, wind, and landing impact.
Dust extraction is keeping up well. Yes, tolerances are spot on. Good. Moving to the frame plates now.
This batch looks good. Clean edges.
Good. Machine is cycling.
Got the new one. Perfect.
Great. Stack it with the others.
After cutting and molding, each frame is trimmed, polished, and inspected. Laser scanners check the alignment of the arms and motor mounts. Even a small mistake can affect the drone's balance in the air. Next, the factory builds the motors. Most modern drones use brushless electric motors because they are powerful, efficient, and reliable. Fine copper wire is wound around motor stators. Magnets are placed inside the rotor. Bearings are pressed into the motor housing so the motor can spin smoothly.
Initiating the winding sequence. Tension is stable, wire is feeding smoothly. Coils are forming perfectly, maintaining oversight.
Each motor is tested for speed, vibration, heat, and efficiency. Bad vibration can damage camera footage and reduce flight stability, so the motors must be carefully balanced. After that, the propellers are made. Propellers are shaped from lightweight plastic or carbon fiber composite. Each blade must have the correct angle to create lift. If one blade is heavier than the other, the drone may vibrate during flight. So every propeller is trimmed, polished, and balanced before it moves to assembly. Now production moves into the electronics section.
Curing looks stable.
Good. Checking the finish now.
This one has a slight warp.
Noted, we'll log it. Boards are entering the oven now.
Confirmed. Temperature profile is stable.
Good. Let's keep monitoring.
Agreed. Looks good so far. First ESC board looks good. Now for a closer look.
Here, electronic speed controllers, also called ESCs, are built on small circuit boards. These controllers manage how fast each motor spins. When the drone needs to rise, turn, hover, or move forward, the flight controller sends commands to the ESCs. The ESCs then adjust motor speed instantly. Next comes the flight controller. This is one of the most important parts of the drone. It helps the drone stay stable by reading data from gyroscopes, accelerometers, barometers, and other sensors. The flight controller makes constant corrections every second. If wind pushes the drone, it adjusts the motors to keep the drone balanced. Then the AI system is installed. This is what turns a normal drone into an intelligent drone. The onboard AI processor helps the drone recognize objects, avoid obstacles, track movement, and understand its surroundings. Cameras, lidar sensors, ultrasonic sensors, GPS modules, and communication antennas are installed into the drone body. The vision system must be carefully calibrated. If the cameras are not aligned correctly, the drone may misjudge distance or fail to avoid obstacles. Many AI drones also include a camera gimbal. The gimbal holds the camera steady while the drone flies. Tiny motors inside the gimbal adjust the camera position in real time, helping produce smooth video even when the drone turns, climbs, or moves through wind.
Alignment looks good, just need to check the focus.
Right, let's use the left board for reference.
Adjusting the lens now.
Perfect. Monitor shows the image is sharp.
Confirmed. We're calibrated.
Initiating drone scan of test batch 4. Target 03 is mobile. Tracking now. Poles and boxes scanned. Vision systems nominal. Radio board installed. Connecting antenna. Running signal test now. Connection confirmed. Lights are blinking green. Gimbal is assembled, starting stabilization test. Motor movement is smooth, no jitter. Tilt test complete, gimbal is stable. Let's point it at the chart and check sharpness.
Image is up, the reds look a bit soft.
Okay, adjusting the focus now.
Better. The circles are resolving now.
Perfect, we'll lock that in.
In another section of the factory, the battery pack is produced. Lithium battery cells are inspected, grouped, welded, and connected to a battery management system. This system monitors temperature, voltage, charging, and remaining flight time. Each battery is tested for safety before it is approved. Now the main assembly begins. The drone frame is placed on the assembly line. Technicians attach the motors to the arms, connect the ESCs, install the flight controller, mount the AI processor, add the cameras, fit the gimbal, connect the battery bay, and route the wiring through protected channels.
Initiating thermal safety test on the drone battery pack. Temperature sensors are active, monitoring the rise. Approaching peak temperature, test is stable. Initiating discharge cycle on the first row.
Confirmed. Indicators are responding correctly.
Safety parameters are stable, no alerts.
Good. Proceeding to the next batch. Routing these through the protected channels now. Securing with a zip tie and a cable sleeve for protection. AI processor and flight controller are seated, checking connections now. All connections are secure, proceeding to shell closure.
Every screw is tightened carefully. Every connector is checked. Every cable is arranged neatly so nothing becomes loose during flight. Once the drone body is closed, the propellers are attached. At this point, the AI drone looks complete, but it is still not ready to fly. First, it must be calibrated. Factory software is installed. The flight controller is configured. The AI vision system is loaded. The camera is tested. The GPS is checked. The compass is adjusted. The motors are spun at low speed. The drone is placed on a level calibration platform so its sensors can understand balance, direction, and movement.
Gimbal is locked, camera aligned.
Prop balance looks good, no vibrations. All sensors are green, ready for calibration.
Okay, let's check the ESC.
Ready.
Finalizing the connection, ready to upload.
Looks secure, initiating firmware upload. Monitor the logs.
Firmware complete, uploading AI vision software.
All systems green.
Let's start with the gyroscope and accelerometer. Drone is level, running the calibration now. Now for the compass, rotating the drone. Perfect, all systems are green.
Starting low-speed motor spin test. Propellers are rotating gently. Vibration and sound are within normal range. Test complete, shutting down.
Then comes the most exciting stage, flight testing. Inside a safety net test chamber, the drone performs its first hover. It lifts gently from the floor while engineers monitor vibration, drifting, motor sound, battery behavior, camera stability, and wireless signal strength. Next, the drone performs turning, climbing, landing, obstacle avoidance, target tracking, and return to home tests. If anything fails, the drone returns to diagnostics. If it passes, it moves to final inspection. In the final stage, technicians clean the drone, inspect the camera lens, check the propellers, scan the serial number, verify the software, and test the battery connection. Then the drone is packed with its controller, charger, spare propellers, cables, and accessories. After design, frame production, motor assembly, electronics installation, AI calibration, battery testing, software setup, and flight trials, the AI drone is finally ready for the real world. It can inspect buildings, scan farmland, assist emergency teams, deliver small packages, capture cinematic footage, and explore places humans cannot easily reach. And that is how AI drones are made inside a futuristic drone factory. If you enjoyed this factory process, subscribe, turn on the notification bell, and comment below. Which futuristic factory should we explore next?
Starting with the propellers,
They look clean.
lens is clean,
Battery port is secure.
landing legs are stable,
Looks good.
Lens alignment is spot on. Now for the gimbal tilt. Perfect response, it's ready.
Ready for final scan. Scanning now. No readable text. Approving manually. Approval complete.
Drone secured in the foam. Charger in place. Propellers arranged. Controller positioned. Cables tucked in. Batch is sealed tight. No issues.
Good. I'll scan them through.
Looks clean. Keep the pace steady.
Will do. Next set is clear.
All right, bringing this pallet in.
Got it. Steady on the ramp. Clear in the back. Guided in.
In position.
Secured. Looks good. Drone online, commencing inspection. Wind is steady, fly safe. Good hover, proceed with scan. Data confirmed, next panel. Drone's online, feed is live.
Roger. Scan the riverbank.
Copy. Drone heading to the river now.
Good. Mark that ridge as a waypoint.